Welcome to Section 5, Storage Options and Encryption at Rest. In this section, we are going to cover a few concepts about AWS services for storage and encryption at rest, like S3 object storage and Glacier, ephemeral and EVS volumes, shared storage with EFS, migration options and storage gateway, and also finally we will end up talking about RDS, the Relational Database Service. Let's start with S3 object storage and Glacier. In this video, we are going to talk about the storage options, a review about the options that we have available, definitions, how S3 encryption works, and how we can use Glacier and its encryption. AWS has multiple storage services. As we can see here, we have from ephemeral drives, the EC2 instance storage, or elastic block storage, EVS, elastic file system, S3, Glacier, etc. We will see here a few of them and how encryption works with them. So remember, most of these services, all of them, have an encryption option and different ways to secure your data on them. We are going to review a few of them, the most important and popular. Let's start with some definitions. What is object storage? I like this definition from the Wikipedia that says that object storage is a computer data storage architecture that manages data as objects, as opposed to other storage architectures like file systems, which manage data as file hierarchy, like any other storage, like block storage, for example, or file storage. As we can see here in the description, block storage manages data as blocks within sectors and tracks, but are also file storage, for example, that manage data a different way. So why is important to understand what is an object storage, which every object is stored as a unique URL, and in most cases is accessible via an URL and a unique ID. This is important because S3, Amazon Simple Storage Service, use object storage. It's the object storage service in Amazon Cloud. So this service has 9s of availability because every time that you upload content to S3, it's replicated at least in 3 availability zones. So this is why provides high level of durability, availability, and also parallel throughput, which allows you to upload information very quickly. So with S3, there is no minimum amount of data or a limit. You don't have to reserve size of your bucket. So you pay only for the amount of storage that you use in S3. Each object has a unique URL as a common feature in object storage. And also you can access using the API. In addition to that, S3 has infrequent access and S3 reduced redundancy storage. S3 RRS redundancy storage has 4 9s instead of 9 9s of availability time, hence it's cheaper. S3 IA infrequent access has the same availability and durability but with less throughput. So when you upload data to Amazon S3, you have to choose between what type of storage you want to use actually, what type of access and availability you need. Remember, you can have more or less throughput and also more or less availability. And finally, Amazon Glacier, which is a service known as cold storage, is used for archiving and backup. Like any service for archiving or backup is valid, of course, for less used or infrequent accessed data. Data is stored as archives, and archives are stored in vaults, and you can access to it using the API and also the management console. So if we are going to store data in those services, we need to understand a little bit more about what is encryption at rest and why it's important. So we know that there are many policies and regulations that make us to protect our data and require the data encrypted when it's stored. That's what we call as encryption at rest. So we have data, we have an encryption algorithm, and we have a key. And all together we can encrypt that data at rest. So we can use encryption at rest in 2 ways. Using client-side encryption, which is when you encrypt the data before upload it to the service to be stored, and also is unencrypted or decrypted when you using your application, when you download it. Server-side encryption is the encryption that happens when you upload it to the server, and the server manages that encryption. We will see that in S3 as well. And we can use AWS KMS, the Key Management Service, and AWS Cloud HSM. It depends on our requirements and needs. So from the key management standpoint, we can see three different models. So the model A, let's say, call it model A, where a customer controls the encryption method and the entire key management infrastructure. This is, for example, when you want to use your own application and client-side encryption, for example. The model B is when the customer controls the encryption algorithm and the key management infrastructure, but the key is stored in AWS. For example, when you use AWS Cloud HSM. And model C is where AWS controls everything, the encryption method, the entire key management infrastructure, etc. For example, when we use AWS KMS, which is one example that we'll use here. More about S3 encryption at rest. So as we saw before, client-side encryption encrypts your data before upload it to S3. So decrypt the data as you download it in your application and vice versa. So you download it in the application and decrypt the data. You can use open source tools or third-party tools like AWS partners with encryption tools to do that. Or use also the Amazon S3 encryption client using the SDK. On the other side, on the server-side encryption, also known as SSE, we have different options. SSE S3 is where AWS manage keys. AWS manage and protects the unique key to encrypt data. Okay, and that key is encrypted with also a master key that is rotated monthly and stored in a different and secure host by AWS. So your POT action, and using the API, the put request, you have to send it with encryption info. And also you need your bucket to have a policy to enforce the encryption. We will see that policy later. And implement it the advanced encryption standard AES 256-bit. Another option is SSE KMS, is when we use AWS KMS to provide, create, and manage our encryption keys. So, of course, as in SSE S3, SSL usage is mandatory. If you don't use SSL when using the API, we are going to get an error. So you have to use SSL for put and get methods. And same way as the other option of server-side encryption, you need a policy in your bucket to enforce encryption. The final option that we have is SSEZ, where the customer provides keys. So you can provide the keys, the management of the key and encryption is done by AWS. And you can do all this stuff using the SDK. Also, there is another option to protect your data in the cloud that I like to highlight, which is MFA delete or MFA access, which means that you can enable multi-factor authentication if you want to force using MFA to delete or even access to that data in your bucket. And this can be configured using the SDK. When it comes to call backup or archive or backup with Glacier, remember that by default all data in Glacier is encrypted on the server side. Amazon Glacier manage everything about that, like the key management and the key protection, and uses also advanced encryption standard 256, with 256-bit is the largest key size defined for advanced encryption standard, so we are fine with that. So also if you can use your own keys, but you have to encrypt your data before you upload your data to Glacier. Okay, so let's see a little bit how it works and how to configure our buckets to, for example, enforce encryption. We are here in the AWS console. Remember, in our account, I'm logged as admin with an user that has administrator privileges. But in this case, I'm going to go to S3, and here we have different buckets. As you see, none of them are public accessible. And I want to show you the pack training encryption 1. In this bucket, I have already one document, one PDF document, so we can upload documents using the upload option, etc. But let me show you a few properties and permissions. So here in properties, I have versioning enabled. That means that every time that I upload a document where that document exists, it's going to create a new version, of course. We can enable server access logging. we can enable object level logging, etc. Or even if this is an static website hosting, we can also enable. But the option I wanted to show you is the default encryption option. So in this bucket, I have server-side encryption S3, the S3 option. Okay, this is the very easy way to do that, where AWS manage everything and we can make sure that data is stored in the bucket. So, but also, in order to enforce that option, we have to add a bucket policy. Let's go here to permissions. In permissions, we can come here to bucket policy and see the policy that we are saying, okay, deny any put object to this resource, which is actually the bucket, if it doesn't come with this encryption in the option. And the same if the server-side encryption has to be true. Okay, so this is the way that we are forcing any upload to be encrypted, to force encryption in the header. Otherwise, it's not going to be encrypted and it's going to fail. For example, if I come here to the bucket and I upload any document like this one, I click upload, it's going to fail because I didn't specify encryption. Remember, here in permissions, we have the bucket policy where we can also implement some restrictions, what to allow or not to do with this bucket, and also access control list, where is the original way to control who can access to your data in your bucket. Okay, but for advanced policies, we have the bucket policy itself. And to see the packet training encryption 2 bucket, in this case, this bucket, I have configured different encryption. In this case, is using AWS KMS, and I choose this particular key, the training key. And if you come here to permissions, I forced this bucket with a policy saying that the encryption has to be with KMS. If it's not KMS, if we upload that data, an object without KMS encryption, it's not going to be saved and it's going to fail. So as a summary, we have seen the different storage options. We have seen some definitions to understand S3, Glacier, object storage, how S3 encryption works, and Glacier encryption.